Good morning, everybody. Thanks to be here for this webinar on WS PGRADE. The aim of this webinar is to introduce you WS PGRADE. WS PGRADE is open source tool to develop web portal based on LifeRay. It is able to interact both with grid and cloud resources, and it's mainly based on the concept of workflow. Then you can deploy within we can deploy through WS PGRADE a workflow on the infrastructure that is made of different nodes that can be executed in a certain sequence according to how you have defined the workflow. This webinar is organized with a first introduction on the WS PGRADE. The presentation will be done by Peter Kasux, and then Peter and Zoltan will give us a short demonstration on how WS PGRADE could be used. This webinar is very relevant, in particular for the community that's attending this meeting, to understand if the feature offered by WS PGRADE can help them to facilitate the integration of their application within the EGI infrastructure. Okay, Peter, you can start when you want.
Okay, Diego, thank you very much for the introduction, and welcome everybody. So the talk is about basically the workflow features of WS PGRADE, but of course there will be many other things as well. The first slide is about the basic features. So this is based on LifeRay. It's a general purpose science gateway framework, and basically workflow-oriented framework. It supports the development and execution of workflow-based applications and supports the fast development of domain-specific gateways by customization technology. So it means that WS PGRADE is a framework, and if you install this gateway based on the framework, then you can customize it, as I will explain you later. When we started the design of WS PGRADE, the main aspect of the design was flexibility. So I tried to show you all those features which demonstrate this flexibility. So first of all, this is the architecture. As you can see, there are several layers. The bottom layer is the infrastructure layer, where you can access high throughput computing infrastructures, high performance computing infrastructures, and also a large variety of data storages. On top of that, there are two services. One is the DCI bridge, by which you can access the HTC and HPC computing infrastructures, and the data avenue, by which you can access the different kind of storages. These are part of the GUs layer. The next layer of GUs is about supporting the workflows. So it provides the workflow management, a workflow repository, and also it provides internal storages to store the different data, structure of the workflow, and so on. So these two layers are the GUs layers, which you can consider as a kind of high-level grid cloud middleware layer, if you like. On top of that, there is the user interface layer, which is called WS PGRADE, and it contains, first of all, a workflow editor. This is a graphical workflow editor. Then there is a workflow execution monitor. So if you run your workflow, you can monitor what's going on either in the grid or in the cloud, and so on. And there is a graphical user interface for the data avenue service as well. You will see later. So this is the framework. And on top of that, you can create application-specific gateways. Here I just mentioned three of them: the Visivo gateway, which was developed in Catania, a Proteomics gateway in ETH Zurich, the Mosgrid gateway in Tübingen University in Germany. But as you see in the figure, more than 30 gateways, customized gateways, have been developed inside the Sybase project. So in fact, the WS PGRADE GU's history is quite long, but the major developments happened in the framework of the CYBOS project, which was finished about 1.5 years ago. But since that time, still we continue the development of the gateway framework inside several projects, like, for example, the EGI Engage project, the Vialecta project, which is for astronomers, and the Cloud SME project, which was for companies. So first, let's see the workflow parallelism, how we can provide flexibility in workflow parallelism. These are the three components which are support this feature: the workflow editor, workflow execution monitor, and workflow management. So this figure shows you a typical picture of a WS PGRADE graph. The nodes represent the jobs what you want to execute or services what you want to call, for example, in the grid or cloud environment, or you can actually put here an embedded workflow as well. The ports represent those input and output files by which these components can communicate to each other. And also the arcs represent this communication connecting the different ports. So transferring files as output files from one node to the next node as input file. The semantics is extremely simple. This is an absolute data-driven or data flow graph. And the semantic is that if a node can have all the input nodes which is needed for this node to be executed, then the node is really executable. So when all the files are available, the node is executable. And then the workflow manager recognizes this situation and starts the execution of this node. A very typical template to execute workflows is the so-called parameter sweep workflow template. Here you can see that it has basically three nodes. The first node is the generator, which divides the big parameter sweep file into small files. And for each such small file, there will be a sequential code to be executed. So if you divide your input file into 1,000 different small input files, then you can run the sequential node 1,000 times for every different input data. So this way you can actually easily scale your application in the cloud depending on the size of the small input data, how many packages you create. You can create a lot of parallelism for your code. And of course, every sequential execution will generate an output file. And then the final node in the template is the collector, which is taking all these result files and then doing some statistics, trying to find the best result or whatsoever. You can put whatever code you like into the collector, into the generator, and also into the sequential node. This is very typical, and Zoltán later will show you a demo, which is the Autodoc Vina application and working exactly based on this template. Now, considering the achievable parallelism, the very first thing is that if a node is an MPI node, if you run an MPI node in the cloud where you have, for example, 16 core in that virtual machine, then you can get parallelism in that virtual machine. You can get MPI parallelism inside the virtual machine. Then, of course, you can have parallel branches in the workflow, and you can start as many virtual machines in parallel as many parallel branches are in the workflow. And then, of course, you have seen already the parameter sweep parallelism in the previous figure, and the whole graph could be considered as a parameter sweep application. For example, you can embed such a graph into the sequential node of the previous figure. Okay, if we go back, here, this internal sequential node could be a complex parallel sweep application graph. Okay. The next question is what kind of DCIs, distributed computing infrastructures, we can access by WS PGRADE. So here you can see that through the DCI bridge, you can access actually different kind of HTC and HPC infrastructures. So here you can see that we can access different kind of clusters like PBS, LSF, MOAB as SunGrid engine. Different kind of cluster grids like ARC, GLIDE, GT2, GT4, GT5, Unicore. Different kind of supercomputers like Unicore, XSEED-based supercomputers. You can access desktop grids based on Boeing. And of course, you can access the clouds of the EGI Fab Cloud. Now, in order to access all these different infrastructures, you need different kind of certificates. And we support both the individual user certificates and the robot certificates. Now, let's focus into the cloud. Here again, there is several layers of flexibility. The very simplest solution is that a workflow node could be a kind of submitted job, which you can submit to the cloud, and then it will be executed in the cloud. You will see in the demo that Zoltan is showing exactly this kind of solution. The other solution could be that the workflow node is actually a service, and when you execute this workflow node, the result will be to create this service in the cloud. And more or less the generalization of this aspect is the third item in this slide, in which case the node can represent the creation or deployment of a complete virtual infrastructure. For example, a Docker cluster could be installed in the cloud, or a Hadoop cluster could be installed in the cloud. And then the next node of the workflow can use that Hadoop cluster. You will see later an example like this. And this is actually when we create this in the most general way that we result in what we call the infrastructure-aware workflow concept. So going through the different possibilities, how to use WS PGRADE in the cloud, this is the simplest one, is what we call the GUse wizard for novice cloud users. In this case, you can run a parameter sweep application. So if you have got an application, for example, MATLAB, and you want to run with many different input files, then you just drop this application into the wizard, and then going through the 6 steps of the wizard, your application will run in the cloud as a parameter sweep application. Zoltan will show you in detail in the demo, so I show you here only just 2 representative slides. So the first one is showing the third step, when you give as parameter the different input files as parameter sweep files. Okay, so exactly as you remember in case of the parameter sweep workflow template, it was the generator who created all these parameter sweep files. Now here in this case, it is the user who should provide all these files. Of course, it could be taken from a directory. So you can prepare in a directory all these files, and here you just provide the name of the directory. And another important and very characteristic feature is the 5th step, when you actually ask for the cloud, which cloud site you would like to use, and what kind of instance you would like to use, a small instance, a medium instance, or a large instance. Now this feature is currently available only in the long tail of science gateway. The Fat Cloud gateway is not implemented yet, this 5th step, but if there is a need, we can absolutely quickly put into the deployment as well. This is another very representative figure. So here you can see that the gateway itself can run in a cloud, for example, run in the Chestnut cloud. And then you can use this gateway as a kind of PES service, where you can develop workflow applications, cloud applications, and then you can save these cloud applications as an SaaS application. And here you can see that in this simple example, you have 4 nodes, and the different nodes can actually run into different clouds of the EGI Fab Cloud. Here is another example, which is again a kind of parameter sweep application, but here we explicitly show the different nodes for the sequential node, and also we can explicitly say where to run these nodes in which cloud. Now here is the Hadoop application I mentioned. So in this case, you can have 3 different nodes. One is to deploy the Hadoop application in the cloud, then to execute a MapReduce application on this deployed Hadoop cluster, and then to destroy the Hadoop cluster from the cloud. Actually, this was developed by University of Westminster, and they have already gave a webinar how to use this feature, and therefore I don't go into the details now. I just mention you that this is available. And this is the example showing how it's actually using WS PGRADE to run the application in several clouds using the slave DCI bridge through which the concrete Hadoop node are created, and then this can access the different kind of storages. Let's say sample application could be taken from the Shiva repository, and then you just modify the parameters of this application, and based on that you can very quickly and easily create a running Hadoop application in the cloud. Right, now here is described how to use it. So if you go to this web page, then you can get all the information, how to import Hadoop workflow, how to download the customized sample configuration, so on. So as I mentioned, I don't want to go to the details. And this is the final generic solution for the infrastructure level workflow, which shows you that in such a workflow, at any point of the workflow, you can put nodes which deploy different kind of infrastructures, for example, a Hadoop cluster or a Boeing system, and then you can place other nodes in the workflow where the deployed infrastructure is actually used by these computing nodes. So for example, this MapReduce node is using the Hadoop cluster, and this Autodoc workflow node is using the deployed Boeing infrastructure. The next issue is accessing data storage. For this purpose, we have the Data Avenue user interface, the Data Avenue service, and of course, in the infrastructure, we have a lot of storages. The data structure access is based on the Data Avenue Blacktop service. This provides, or it supports a lot of different storage protocols like HTTP, HTTPS, FTP, GSI-FTP, SRM, IROS, LFS, and S3. So it's quite a number. And if you need more than that, of course, you just tell us, and we will see how easy or difficult to connect that new kind of storage. Usually, this takes several weeks. And we provide this Data Avenue Blacktop service in Stocky, and then we provide the user interface on top of that as well. So if you go to this Data Avenue at Stocky web page, then you can actually transfer files from the different storages. Also, in the WS PGRADE gateway, we provide a portlet which has exactly the same user interface as the data WS stocky user interface. So the same way you can transfer files here and there. And of course, if you have a liferay based other portal, still you can use the same portlet in that portal. If you go to the web page, here you see the web page address URL. There is a video, and then you can get all the major information in that video. So again, I don't go into the details. One important point I didn't mention yet, that inside the workflow, when two nodes would like to communicate through a storage, this is also supported by the Data Avenue service. So for example, here, one job running in a GT5 grid, for example, can place the output file into an S3 storage, and then the next job, which is, for example, a GLI job, can access that S3. But of course, any of them could be a job which is running in the cloud, or all of them can run in the cloud, and no matter where the data is, they can access through the Data Avenue. I think this is a very, very important feature, because if you access the data always through the Data Avenue, your workflow will be absolutely portable between different clouds and between different grids and clouds. The next issue is collaboration among community members. For this purpose, we provide a workflow repository inside the gateway. So if several users use the same gateway and some of them develop workflows, they can publish this workflow in the internal repository, workflow repository of GUs, and then other users can download from the workflow repository and immediately run these applications. Of course, you can have several gateways, all of them WS PGRADE based, and they can collaborate if you use the Shiva workflow repository. Then the same way as you place your workflow inside the GU's portal, you can upload your workflow from the GU's portal repository to the global Shiva repository. And it's just one click. And then another WS PGRADE gateway user community can download from the Shiva repository the same workflow, and they can execute on their own system. It was developed in the Shiva project and was exploited and used in the Airflow project. The next issue is the workflow management point of view is to integrate into WS PGRADE gateway not only WS PGRADE workflows, but you can use also Taverna workflows, Galaxy workflows, Kepler workflows, and so on. This feature was developed again in the Shiva project and used in the Airflow project. And it really nicely demonstrates that different communities can work together. They can share workflows through this feature. The next flexibility point of view is the type of gateways by which you can exploit the WS PGRADE features. So you can create generic purpose gateways, for example, clouds. This was done in the Greek EGI, for example. You can create generic purpose gateways for specific technologies, which was done in the Shiva gateway. And you can create domain-specific science gateways. For example, in the Cybus project, there were, as I mentioned, quite a number, more than 30 domain-specific science gateways created. And here in this figure, you can see the possibilities how to create this kind of domain-specific gateways. One possibility is to use the end-user interface. The other one is using ASM API, which is the application-specific API. And the third one is the remote API. The next slides show an example for each. The first one is the end-user view-based gateways. It means that someone placed a workflow in the internal workflow repository, and then other people can import the workflow, customize, execute, and monitor. And this is automatically generated by the gateway itself. I mean, the user interface is automatically generated. So for example, here is a gateway which is based on this feature. This is an Autodoc gateway. Here is the user interface to access the workflow from the workflow repository. Then the user interface to give the parameters for the Autodoc application. Then you can execute and then monitor the execution. And all of this requires that the workflow developer develops, of course, the workflow, configure the workflows, create a template out of this workflow, and then export this template and application to the repository. Unfortunately, I have no time to explain in detail how to do this, but of course there is a lot of manuals in the GEUS website and also in the SourceForge GEUS website. Something like 16 manuals are available, and one of them certainly is describing this feature. Now the second option is to use ESM API. This is recommended if you want to create a nice user interface customized for your user community. In the previous case, in the end user, automatic end user mode, you have only those interfaces which are automatically generated by the portal. So these are not so nice. But if you want to really nice portlets, then of course you can create whatever kind of graphical portlets. Here in this example, for example, in this seismology science gateway, you can see several nice figures as examples for these ASM-based portlets. And of course, behind that is a workflow. And finally, when you have your own user interface and you don't want to touch because it's already available, but you would like to run workflows from this user interface, then, for example, a good example, the Institute of Physics Belgrade Science Gateway, they created a WS PGRADE gateway just to develop the workflows. And once they develop the workflows, they use their Identity on gateway through the remote API to run these workflows. And of course, again, here is their original user interface and so on. Now, considering the technology adaptation, so I mentioned that more than 30 gateways were generated in Cybus, but beyond that, we know that more than 100 gateways are created all over the world. From the point of view of using SourceForge, nearly 22,000 downloads have been done so far from 80 countries. If you want to get more information, then please visit this website. And also I can recommend this book, which describes a lot of experience what we gained in the Cybus project. The half of the book, the first half of the book, describes the technology, including, of course, the workflow and the execution management technology. And the second half contains use cases from the different science gateways, customized science gateways. So all this I mentioned already, described in detail in this book. So finally, the conclusion, why to use WS PGRADE GEUS? I can recommend from 5 points of views. First of all, from the point of view of robustness, you have seen that already large number of gateways used in production. So this demonstrates that this is a robust technology. From the point of view of sustainability, we still continue to further develop this gateway within the EGI Engage project, especially the Daria Computing Center. From the point of view of functionalities, it provides a very, very rich set of functionalities. And we learned in Cybers that practically it was enough always for those communities. The other thing is how easy to adopt the gateway framework for your user needs. Again, we can say that based on this customization technology I mentioned, either the remote API or the ASM API or the end user interface feature, you can very easily create the kind of gateway your community would like to have. And finally, you can influence the progress of WS PGRADE GUs. We are very happy to collect new requirements, feature requests, and so on. And then, of course, if we have the manpower, we are very happy to install them. So thank you. That's it.
Thank you very much, Peter, for your presentation. For the question, Peter, what do you prefer? We can have the discussion after after the demo, or do you prefer to have the questions now?
Well, I would recommend to see first the demo because it will give even much more details than I explained.
Okay, perfect. Then, Zoltan?
Yeah, I think I should click on request control, right?
Yes.
Okay, so can you hear me now?
It's loading.
I think that my screen is also on. Is it right? Can you see my screen?
Now, yes, I can see it.
Okay, perfect. Okay, so Peter mentioned at least two demos. I would like to start with the trivial one, which is our job wizard. So this job wizard can be used to run simple applications on the EGI federated cloud infrastructure, either single instances of an application or parameter sweep version of your application. These are the 6 steps on the left-hand side you have to go through. First, you have to upload your executable. Afterwards, you have to upload your static inputs, which all instances of your application will receive. Afterwards, it's optional to upload parametric input files for your application. Next, you have to specify the command line arguments, if any. And after that, you have to select a resource on which you would like to run your application. And finally, you have to define the set of output files your executable will produce. And basically, there are 2 panels in this wizard. On the left-hand panel is this application configuration, and on the right panel, you can see the already executed applications. For the given application instance that was already executed, you can perform different operations. You can download the outputs. You can download the whole workflow with all the log files and things like that. You can abort an experiment which is running. You can remove an experiment if you are not interested anymore in that, or you can clean the whole list by clicking remove all experiments. Okay, now what I would like to show is how to run the Autodoc application. This Autodoc application is performing molecular docking simulations. It requires a configuration file for the Vina application. It needs a receptor molecule, and it also requires a set of ligand molecules which will be docked against the receptor molecule. Okay, so first I'm going to define the executable. I have that here in place on my machine. I have a self-extracting shell script which contains all the necessary files to run the Vino application. So any binary dependencies are included in this file. So I'm simply drag and dropping the file into this input part. Okay, I'm going to the next step. I'm going to define the input files all instances of my job will receive. These are the configuration file for the Vino application and the receptor molecule. Those have been uploaded as well. Okay, and as next step, I'm going to copy the parametric input files on here into the wizard. You can see that I have selected 6 files. This means that 6 instances of the Vino application will be executed. The first one will receive this 1.tgz, the second one will receive 2.tgz, the third one will receive 3.tgz, and so on. And all of the instances will receive the 2 static input files, the configuration and the receptor molecule. Okay, so let's define the parametric input files. So I'm just dropping them here. But what I have to define additionally is the name as the application is going to open this file. And it is ligands.tgz. So before executing the different instances, all of these files that I have now uploaded will be renamed to ligands.tgz. So the executable will be able to find them. I'm not specifying any command line arguments because everything is included in the configuration file. And next I'm selecting a resource. I'm going to use the Chestnut federated cloud infrastructure to run the experiment. And as last step, I need to define the output files. Yeah, it can happen that you don't use any output files, but my application produces the output.tar file. So I will have 6 jobs finished, and each will produce an output.tar output file. Okay, after this I can click on Start Execution. So behind this wizard there is a very simple workflow, which is a parameter sweep workflow, and it arranges the execution of my application on the federated cloud infrastructure. Okay, now you can see that let's order by the start time. There's a new instance there is a new experiment in my list. This is the first one which I have submitted just now, and of course it needs some time to have it have the results produced. The virtual machines which will process the jobs need to be started up, and the jobs and the executables along with the inputs are copied onto these VMs, and they are executed there. And once all of the instances of my application have finished, I will get the results back. But in the meantime, in this progress bar, we will see how the execution of the different instances is progressing. But as I said, the virtual machine startup delay causes that we cannot see anything here right now. Okay, so this is the wizard interface which we propose to be used as the first-time users for WS PGRADE GUs. The other one is the whole workflow interface. Besides the ASM-based end user interfaces, in this original workflow views, the users can define very complex workflows. I'm going to show you one example. Here now I have an Autodoc Vino application prepared, which is a parameter sweep version of the Autodoc Vino application, but it is a bit more convenient than the one I have used inside in the job wizard. This means that I don't have to create a set of packages of molecules to be docked against the receptor molecule. All I have to do is to define a large zip file which contains all the small ligands I would like to dock against the receptor molecule, and I can define the number of packages into which I would like to distribute these ligands into. So okay, let's take a look at the workflow. So here you can see that first I have a generator job, which receives the Wiener configuration file and the receptor molecule, and it also receives all the ligand files I would like to have done. And it simply splits these ligand molecules into as many sets as many I have defined. If I double click on the job, then in the parameter, in the command line argument of this generator job, I have specified 10, which means that I would like to have 10 packages produced. And this will result in 10 instances of the subsequent Wiener application or the job being executed. So if we have adequate amount of resources, then these 10 jobs will be able to run in parallel. And finally, we have a collector job inside this workflow. The task of this job is to parse the results of the different molecular dockings and select the best docking results, which has the smallest energy level or something like that. Sorry, I'm not an expert in this field. Okay, but before I submit this workflow, here you can see the standard job configuration interface of a workflow node. So first, you can define if the given node will actually run a workflow or it will run a binary application. Here we are running a binary application, so we are not embedding another workflow into this node, but we have our executable which we would like to run. The type of the node is cloud, which means that the node will be run on the federated cloud infrastructure. I can select the federated cloud resource. Currently, these two are available on this gateway. I can replicate the settings to all jobs if I want to. I can set the type of the binary. This is a sequential application. Afterwards, I have the possibility to upload my executable, which is currently uploaded. So this is the work unit generator.sh file. And I can set the parameter for the application. And I can also assign a robot credential for this job, which will mean that if a robot credential is defined, then the users who are using this workflow do not need to have their own certificate, but the robot credential will be used to run the job. So this is the job executable panel. We have the job IO panel as well, where we can define the input files and the output file properties for the workflow node. So here I could upload a new ligand molecule set, or I could upload a new Wiener configuration file, or I could upload a new receptor molecule. So it is again important to note that this is the stock WS PGRADE interface. So if someone creates an ASM API-based interface for this, then the users of that interface will have a much user-friendly interface to define the inputs for the application. Okay, and once everything is defined, then the workflow can be saved and the workflow can be submitted if someone wants to. I'm going to do that now, so I'm submitting this workflow now. We can set an optional node for the instance. We also have a debugging option, so before or after an execution of a given node, we can suspend the further execution of the workflow, but I'm not going to do that. And you can also ask for notifications if the workflow state has changed or the workflow has stopped. So you don't have to periodically check what is happening with your workflow, but you will get an email about any status change. I'm not interested in that right now, so I have submitted the workflow. And okay, so now this workflow, this Autodoc Wiener workflow is submitted. If I can do different operations with my workflow, so I can configure, which you have seen previously. I can get some information on that. I can check the details. I can submit my workflow. If there are multiple instances of the workflow running, then I can suspend the execution of all of those instances, or I can export this workflow, if it is working properly, into the local repository of this gateway or to the Shiva repository for other users for later usage. Okay, so now let's see what is going on. In the details, you can see that earlier I had 2 instances running successfully of this workflow, and now I have 1 instance which is still running. I could suspend the instance, or I can check the details. And you can see that the first job is right now in the submitted state. This is hopefully because we are waiting for a free slot on the Chestnut Cloud, because the other slots are occupied by the job wizard's jobs. Okay, so now let's go back to the job wizard and see how my experiment is progressing. Here you can see that, okay, let's order by the start time. So the experiment that I have submitted earlier, the progress shows that two instances of my job have already been sent out to the virtual machines for processing, and the others are still waiting for the virtual machines to be started up. And after that time, those will have further processing as well. I don't know if you can see, but here in the first line, okay, the green has now changed into a more darker green, which means that the job has actually finished. So this is 1/3 of the jobs has already finished for this experiment. The others are still waiting for a free VM. But yeah, it will progress further by time. Okay, let's check if my workflow, I expect that the workflow is still in the submitted status, so we are still waiting for a free slot here. Okay, so you have seen how an already existing workflow looks like, but before having a workflow, first you have to create that one, and for that, first you need to define the structure of the workflow, and for this you can use the graph editor. This graph editor is a very simple a very simple portlet for creating new jobs, defining input and output ports for the job. So this gives you a tool to define the structure of your workflow. So for example, here we can set the dependencies between the jobs. After that, after I have my graph ready, I can set I can save this graph. And once that is done, so I have the graph saved, I can create a concrete workflow which has now all the properties set for a proper execution. So let's select the graph that I have just created. Let's call the concrete workflow the same as my graph is. Okay, the workflow is created. Let's go to the concrete workflow list now. And here is my new workflow. And now if I go into the configure view of my new workflow, I will see the very same graph. But if I double click on the different jobs, first I will receive an empty job property screen because I have just created the workflow from scratch. And after selecting the type of the cloud, I have the type of the execution resource. I will also receive the resource-dependent configuration interface inside WS PGRADE. So I can select the resource on which I would like to run the application. I can browse the executable. So I have, for example, here a very simple shell script which simply copies the input to the output port. So it does nothing special. I can define a command line argument if I want to. Okay, so after I have set the executable properties, I can set the input and output properties. I have written the script so it reads one input file called as input. I'm uploading the data for that. And it produces one output file, which I'm going to call output. Yeah, that's all. And if I do this for all of the jobs, then the workflow will be configured finally. Okay, let's define the executable. I don't need any command line arguments, so I'm not defining that. And here, as you can see, my second job receives the input data from the preceding job. So here I don't have the possibility to upload data because the data will be produced by the previous job here. And again, I'm defining the name of the output file. Okay, that's it. I'm saving the configuration of the workflow. So in the executable and the input file has been uploaded. And once that is done, I can submit the workflow. Okay, so that workflow is submitted as well. Now, finally, I would like to go to the job wizard to see. Yeah, so the workflow is progressing. The input set that I have uploaded doesn't contain a lot of molecules, so should finish in a few minutes. Each instance of my application will dock 10 ligands against the receptor molecule. That should finish in a few minutes. And let's see my concrete workflows. I have submitted the autodoctrina, but that one still, yeah, it is still in the submitted status because it is waiting for a free resource. And I assume that the other one is also submitted because it is waiting for, yeah, that one is waiting for a free resource as well. Okay, so I think that's all. So you have seen the wizard interface, which is available on this gateway, and a slightly advanced of this interface is available on the long tail of science gateway as well. On that gateway, you can select the instance size you would like to use to run your application on. And I think that more resources are available there as well. Yeah, I think that's it. So still here here the application has nearly finished, but I'm going to download now an earlier result for you. Okay, just download the outputs. I will receive a zip file, and if I go into that zip, then you can see that there are 6 directories for the 6 instances of my application, application's execution, and in each of the directories for the different executions, we get the standard error and the standard output of the application. And we also get an outputs.tar, which contains the output file of my application. So if I go into that content, then here we can see the the docking results of the molecular docking. Yeah, okay. I think that's all. So this is the simple interface. And if you are about to create workflows from scratch, then you can, or you would like to use workflows in either the local repository of the gateway or the Shiva repository, you can use the stop portlets to do so. Okay.
Okay, Zoltan, thank you very much for your presentation. I think now we can open the discussion. I would like to ask people interested to do any questions to raise his hand using the button you can find in the top center of the window, of the Adobe Connect window. And any questions? It seems Ines writing there something. Let me give you the microphone. Let me enable your mic in. Can you? No. Okay. Sorry. Okay. Then the question is. If WS PGRADE can be linked to existing data analysis software service. Zoltan, okay. Zoltan, I would suggest to answer speaking.
Yeah. Sorry. So yeah, you cannot talk, but I can talk. So and hopefully she can hear me as well. So you have the possibility to define the usage of web services instead of uploading your own executable. And in that case, you have to define the URL of the web service, and the input files you specify will be added as parameters while invoking the web service. To be honest, I have used this feature years ago, probably, but the documentation contains detailed description on this.
There's another question from Ian. Zoltan, the process time looks a bit slow. How to improve it?
Yeah, okay. So what you could see now was that the virtual machines for processing the jobs were not running. But after a job finishes and the virtual machine is not used anymore, we have a short grace period during which we are not shutting down the virtual machine. So if you are submitting a job after that, then your new jobs will be sent or will start execution basically immediately. So I have a workflow that is a parameters with one, and it runs a total of, I don't know, 20 jobs or something like that in total. Of course, those are very, very short jobs, but after I have run an experiment on the Chestnut Cloud, I still had the virtual machines running, and after I submitted the workflow, in a few seconds, I had the workflow status as finished because the jobs were very short and they could be sent to free resource immediately. And of course, they have also finished immediately.
Any other questions? Okay. If you don't have any other question, I think we can close the webinar. I would like to thanks Peter and Zoltan for the very interesting presentation. I have recorded the webinar and I put the link to the recording available in the meeting agenda today. And I also would like to ask Peter if you can send me the slides so I can upload them in the agenda. Anyway, if anyone is interested to have more information about WS PGRADE, or if interested to have some tests to try it, you can contact Peter Zoltan or me, Evgeny, and the other person of the UCST team, and we will try to organize it. I hope this webinar has been interested, and I would like to say thanks you again for your participation. Have a good rest of the day.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.